Welcome back to our third and final real short video on 2-10 notes. There's one thing I did forget to mention that I need to make sure we finish and address here, and that is finishing up our discussion on endothermic reactions. Remember, those are the ones where the reactant molecules were very stable. The reactant molecules were both very stable molecules, didn't want to break apart. They were certainly chemically stable in that it would take a lot of energy to break them apart. So their bonds are strong. We add a lot of energy, they collide along the correct orientation, and they break apart. When they found new partners, the new partners that they were with, the new molecules they formed, were not as stable, so they would release less energy than it took to break them apart. So it took in more to break them apart than was released. So here's the amount of energy it took to break them apart. That was the activation energy. Down here is the energy that was released as the new bonds formed. Overall energy change went up because this is the energy of the reactants right here. Here's the energy of the products right here. The products have more energy than the reactants. If they have greater energy, then they must have less stability. So it'd be easier to break the products apart. How much energy would it take to break the products apart? The same amount that was released when the products formed. But endothermic, that meant energy was taken in. This is how much we started with. This is how much we ended with. The energy went up, so it had to take in energy. But what would that be like? And this is the new part. What would that be like? How would I know it's endothermic in a reaction container? Well, if I fill this container with water, I put in the thermometer, I fill the container with water, I drop in the white reactant molecule, I drop in the blue reactant molecule, I measure the temperature of the water before the reaction happens, I add energy to break them apart, I add energy to break them apart, there's energy being added, and when we're done, the blue is now with the white, the blue molecules are now with the white. Remember, it took in more energy. So I had to add more energy to break them apart than was released into the water. So what would happen to the temperature in the water? Well, we added more energy to break the molecules apart than was released. So where did the energy come from? The energy came from the water, which is the surroundings, into the molecules, which is the system. So energy left the water overall and went into the molecules in order to break them apart, and less energy was released back into the water. So the overall energy change of the water is to go down. The surroundings temperature goes down. The thermometer would go down. The temperature reading in the thermometer would go down because of that energy moving from the water into the reactants. It would feel cold to the touch because energy was leaving the water to go into the reaction. That's an important thing to consider. Thank you. Have a great day.